So you did some graphing back in kindergarten, right? Okay. Let's take a look at this graph here, and they want us to evaluate. Anybody know the name of that type of graph that's curved like that? Parabola? You heard that term, parabola? You have? And these people have not? I guess you got a much better education than the rest of you. Well, it's something that's got a graph with an x squared in it, okay? But anyway, you know how to do this part, right? Let's find f of 4. So where do you go?
On the floor.
On which axis? On the x-axis, you go to 4, right? 1, 2, 3, 4, and then go up or down to the graph, and what's the value on the graph on the y-axis now? Huh? 1. Okay? You guys tell me what f of -1 is from that graph. Graph's not on my forehead. So what's f of -1? What is it? -6. Good. Okay. All right, so now the next question goes the other way, right? For what, and this, by the way, this graph should, go out like this, right? We would call this the graph of f of x, whatever that function is, okay? So if that graph f of x equals -2, so now you're not looking for -2 on the x-axis, right? You're looking for -2 where? On the graph itself, right? Okay? How many times does that graph hit -2?
Oh, it does on the
It's
bottom.
measured, right? The graph is measured with the y-axis, right? It's the output. So how many times does it reach -2? Huh? 2 times, right? 1, 2, right there, and right there. Yeah?
That's my face.
Sure. That helps. Okay. So what x values give you an f of x of -2? That x equals what?
-1.
Oh, what? -1?
1.
Take that first circle and go up. Where does it hit the x-axis? At x of 1, or the other one is x of 3. Everybody got that? Just going the other way. Going from the output to the input with that. And so every graph has a minimum and maximum value, right? Maybe more than one, okay? So what would you say would be the minimum value, right? In other words, when we're talking about the minimum or maximum values of a graph, it's on the y-axis, the f of x would equal what? What's the minimum value of that graph?
Wait, why is that -6?
Which one? Shouldn't, because somebody said -6. This should just be what? +6, right? Up there? I don't know who told me -6. Anyway, back to part C. What is the minimum value on that graph? Remember, the graphs are always measured on the y-axis.
-1.
The minimum value of the graph itself measured on the y-axis. Up and down. Do you see the lowest part of the graph? Okay. What's the value of that graph at the lowest point? Would you agree it's right here?
That's -3.
-3. Right? When you look at the graph values, it's measuring on the y-axis up and down. What would be the maximum value of this function of that graph? The highest it goes.
Doesn't it go up because you have the arrow?
Keeps going, doesn't it?
Infinite.
Wouldn't it be positive infinity? It keeps going, doesn't it? Okay? So positive infinity. And by the way, what we're talking about would be the absolute minimum, absolute maximums. You can also talk about relative minimums and relative maximums, like between an area, right? Between a region, interval. But right now, that's just the absolute, okay? Let's move down here. Okay, so now we're going to take this other function rule here. G of x equals 2x plus 3. What type of graph do you think that will be? It's kind of familiar, doesn't it? 2x plus 3. Does that look like mx plus b? Doesn't it? Yeah. What's the m? 2. And what's the b?
3.
And the b is where it hits the y-axis, isn't it? And the m is the what? Slope, right? The rise and run. 2 over 1, rise 2, run 1. Okay. Anyway, so they want you to fill out a table here and then plot the points on there. We're going to do that. And I think they had you do that back at Tots Learning Center where you made a table with values for a line. And you had like 8 or 10 values to write. How many do you really need to define a line? How many points? Just 2 to define a line. Right, so they kind of overkill it, but we're going to go ahead and fill up the table, and then we'll pick 2 of them to plot our line and use our straight edge, yeah? Okay, so when x is -3, right, this would be g of -3. It would be 2 times -3 plus 3, right, equals what? It's -6 plus 3, so -3, right? So this is my x, this is my y, isn't it? So what are the coordinates of that point? What comma what? What now?
-3.
-3 comma -3. Okay? We'll do the next one. 2 times what? -2 plus 3. So that's -4 plus 3, which is, and what are the coordinates of this point? -2 comma -1. Get the idea? Why don't you guys go ahead and take a moment and fill out this table, okay? And then we'll plot it. Is everybody able to get those coordinates there? If you missed any of them, fix them. Okay. Well, again, we only need to use 2 of them, right? And then you can use your ruler to connect them. Like if you're only going to use 2 points, would you say you want to pick 2 points really close together or maybe farther apart, you know, for accuracy? Farther apart, right? Makes sense? Okay?
0, 3, and 3.
Yeah, why don't we use this one here, the -3, 3 maybe? Can we even get 3, 9 on there? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay. So let's go -3, 1, 2, 3, down 3, and over to 3, 9, 1, 2, 3, 1, 2, 3. It's the top one, right? And then you can take your straight edge. Do my thing here. Let's see. You want arrows. That. Okay. And then I'll just kind of connect mine like that. Oh, that was special. Try that again. Why is that? Okay, well, yeah. You need arrows. You have to have the arrows on it, right? Because you guys know, like, unless you're told otherwise, you need to have the arrows on it.
Yeah, but you didn't draw your line.
What? There it is right there. I understand. I'm using it for everything. I technically didn't even write the number 2 here because it's digital. It's all zeros and ones. I can't use a ruler on here. So if I touch the screen with a ruler, it makes marks.
Yeah, but do you have a ruler setting?
Yeah, there's a ruler in there. It's obnoxious. I'm replicating what you should have. Like, do you need to see me draw a straight line with a ruler? Or
Yeah.
do you know how to do that?
No, I don't.
Well, then I can't help you then. Okay? Maybe that should be a little thicker. I don't know. What do you think? Yeah. How about that? Better.
It does very well.
Well, other than I just carry. Why is this getting off of there? There we go. Anywho. All right, so you could have gone through and plotted all those and drawn a line through them, okay? But 2 is all you need, preferably 2 farther apart than the others. Okay? Any questions on this one? All right, let's go and graph something now that's not linear, because that was linear, right? What's the base word of linear?
Line.
Line, right? Makes a line. And it's some equation with x to the first power, right? Because, like, you realize that, if you go back here, you see this 2x here? What's the exponent on the x? No. That's the coefficient. It's a 1 up in the exponent, right? X to the first, because there's nothing written, you assume it's a 1 up there, right? So anything with x to the first is going to be a straight line. But on the next one, we have f of x equals x squared. So the exponent is 2. You think that'll be a straight line? Okay, let me ask you a question. Whenever you square a number, what's the result always? Positive. Even if you, let's say you square a 3, what do you get?
9.
If I go ahead and square this 3, I get a 9. If I square this negative 3, what do I get? A 9, right? So you might think that this graph is just going to be in what shape? Yeah, but we call that a what? What was the name? Parabola. So it's a quadratic function, okay? Quadratic meaning it's x squared. Be with me on that? Okay, and the graph will be a U-shape or a parabola. It's also known as nonlinear, but okay. So let's fill out a table here. Now, do you think we'll need just 2 points for something like this? We'll need a little more, right? Right? Probably usually you want like 3 to 5 points to get an accurate parabola. So let's start plugging these in here. So x squared would be negative 3 squared, which is what?
Negative 3.
What?
I'm
Or just 9. And the coordinates therefore would be what? Oh, you were giving me those, I see. Negative 3 comma 9, right? And then negative 2. Notice I'm using parentheses, right? Because without the parentheses, the negative's not getting squared, right? Okay? So it's negative 2 squared. 4. So the coordinates are negative 2 comma 4. Okay? So again, you guys take a minute and fill out the rest of this table. All right, so your table should look like that, those coordinates. Okay? And go ahead and plot these points then. So we got negative 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 3, 9. Negative 2, 1, 2, 3, 4. Negative 1, 1. And 0, 0. And 1, 1. And maybe you notice when you start up the other side, you don't have to go back and look at the table. It's in what? Kind of, it's more of a reflection, right? What? Down here?
Squared.
3 times 3. Huh? Well, you had 6, didn't you?
Yeah.
Okay.
Okay.
All right, so let's see if we can get a. I always think, like, when I'm drawing curves through points, I always, like, as I'm drawing it, I feel like I'm more accurate if I'm kind of looking ahead of where my line is to aim it, if that makes sense. I don't know, some of you guys are fairly artistic and kind of. Okay. Graph looks something like that, hopefully. All right. So this is called a parabola. Parabola, I guess, for kids to pronounce it. Sounds like something you buy at Sopranos. Parabola with cheese. Parabola. All right. And also, I would say, notice the symmetry. You heard of that word? right? You imagine drawing an imaginary line through the middle of it and acting like a mirror. So one side is like a reflection of the mirror of the other side, okay? And by the way, if we do draw that line, I'll just put it in here. It happens to be the y-axis. We'd call that the axis of symmetry. Right?
That looks like a big word. Piecewise divide.
Yes. On to the next type of graph you might run into, or you will run into. And we looked at this the other day, just a word, right? We didn't look at the actual function for one, but a piecewise function. Remember what that is?
No.
Okay. Each part of the graph is a different piece that comes from its own little separate function. Okay? And so it was maybe a straight line, with one slope, and then at some point it turned into a differently angled or sloped line, right? Like that. Okay? So let's take a look at this. Notice the format of this piecewise function. F of x equals, with the bracket there, right? Well, for some values of x, it equals 2x plus 6, right? And that graph's a line, doesn't it? What values of x will this graph equal 2x plus 6? For what? What does it say here? For all x is what? What? Less than 0. What's another way to say less than 0? Wouldn't they be all the negatives, right? These are negatives. And then, once you get to 0, it switches to what? 6 minus x. For x greater than or equal to 0. What would we call that? Those are positive in this case, right? Now, you got to pay close attention. Notice in this first interval, as it's called, okay, that x is less than 0 without an equal to sign, right? And you notice greater than or equal to 0 for the next one. So if we're making a table of values for this, once we get to 0 for x's, which one of these do we use? Right? The one that's equal. So you got to pay careful attention to that, right? Now, you'll have an endpoint here, but when you graph it, will we use a closed or open circle? It's less than without the top part. There's to be an open circle, right? Okay. Let's just fill out the table here. I kind of wish they had. So we need to keep a reference on that, right? So from -3 to what are we using the top one in this table? Huh? Yeah, not the 0. We'll do the 0 for it just so we see where like the open circle endpoint will be. But right, so this will be for the 2x plus 6, right? And then the rest of these will be for the other one. What was it? 6 minus x?
6 minus x.
This will be our 6 minus x part, right? And I kind of want to do the 0 for both. You'll see what I mean in a minute. So let's plug in the 2x. So 2 times -3 plus 6 gives you what? 0, right? And what are the coordinates? -3, 0. Let me just skip down to the 0 because I want to kind of squeeze in there to do it twice. I'm not going to use the 2x plus 6. It's going to be plotted like with an open circle, right? So let me just put 2 times 0, like up top here, plus 6 equals what? 6. Right? Mm-hmm. Doesn't it? Okay, now let me do the 0 with the 6 minus x. You'll see what I mean in a minute. 6 minus 0 is what? No, just 6. Oh, they're both 6 anyway. But one of them is going to have an open circle, one will be closed when we graph it, right? So the coordinates here are going to be what? In either case, 0, 6, right? All right, why don't you guys go ahead and fill out the rest of this table. Make sure you're using the proper interval. Yes? The nurse? Everybody have the proper table of values here? Yeah? Okay. So let's start plotting. I'm going to go ahead and put all these points in here, right? Just because I want to show you what happens at this particular turning point here, right? Okay, so we got negative, oops, negative 1, 2, 3, 0, and then negative 2, 2, and then negative 1, 4, that, and then 0, 6, right there. Do they both share 0, 6? Okay, so even if we include an open circle for this one, even though that's not included, this one would be a closed circle, and so it should be a closed circle, right? What did you say about a Christmas tree?
When you finish it, it looks like a Christmas tree.
Oh, I'm so excited. I can't wait to see.
I love Christmas.
5, 2, 4, and 3, 3. Okay? So you probably want to do your straight edge now like this. Yeah, I'll do that. That's fine. Well, I'll use one arrow. Then I'll come from up here. Yeah, well. Why am I? Did I get one of these points wrong? I think I did. Something went wrong there. So I got, let's see. So 0, 6, and 1, 1, 2, 3, 4, 5, and then 2, 1, 2, 3, 4, and then, oh, 3, 3, that's the one. I didn't count. I don't count good. Oh, there's more to math than counting.
It's a big part.
Oh, it's overrated. Am I recording? Yes, I'm recording. What the heck? That. All right, let's do that. Now they're all kind of hidden. All right. Okay, notice you put arrows at the ends, okay? So you notice the one graph goes up like this, right, until we get to that x of 0, and then the other one takes over. I said it's supposed to be a V?
No, you didn't.
Oh, not this one. This one up here. That's a quadratic.
Oh, so this being
Yeah, this is not a quadratic. It's linear, right? So, like, if you were to make that kind of U-shaped up there, that part of it wouldn't be an actual straight line, right? So not linear. That's what it is linear. All right? All right, so you kind of get how a piecewise function goes. When you make a table, you have all these x values. You try, well, which one of these do I use for this x value? When you look at the interval here, say, well, the x value I'm looking at, what one of these does it fall into, right? And that's the one you use. You guys get that part? And sometimes you'll see these with 3 or 4 or 5 even, you know, just big deal. Okay? All right, let's move on to some Regents questions. Okay. So we're on page 191. Everybody take a minute and read this over here. It's about a snowstorm. And what we need to note as you're reading it is like what time the storm starts and how long each different thing happens, right? Because I want to figure out at like what hour we make a change when we go to graph this. So read this over. All right, so hopefully you read it a little bit. So this is a little bit like ones we've looked at, right? But in the ones we looked at before, they gave us the graph that had the different levels and, you know, distance from home. If they're, you know, just the one delivering a pizza was at the door for 3 minutes or something. It was horizontal like that, right? Nothing's changing, okay? So let's take a look at this. First of all, I want you to take a note. What is the interval here for the graph on the vertical axis? What are they counting by? So this would be 0.5, right? This 0.5 and then 1 and then 1.5, right? 2, 2.5. You get the idea? Okay. And what about across here? Just by ones, isn't it? 1, 2, 3, 4, 5, 6. Okay. Let's go back up here and read this first part about the snowstorm. What time did the snowstorm start? Anybody?
No.
It started at the first 4 hours? At midnight, right? Okay, then something happened for the first 4 hours, okay? So during the first 4 hours, okay, that goes from midnight to what time? That would go to, so this would be 2, 4 a.m., right? Okay? It snowed an average rate of 1/2 inch every hour, okay? So from midnight to 4, so I want to kind of do this. Let's go out here to 4, and maybe very lightly, let's just put, well, let's just say instead of 4 a.m. because I think we'll probably end up getting past noon, maybe.
Yeah.
Yeah. So let's just say, yeah, to 4 hours. Which is clearly 4 hours, right? Okay. And so that part of the graph is going to go from, here's midnight, right? And here's 4 hours, right? So maybe I want to put like a lightly dotted line down here. So you could probably do the same thing, right? And that way, it's like, as we're going up 1/2 inch every hour, right? We know where to stop doing that, okay? Then let's look at the next interval, okay? So after 4 hours, right? The snow started to fall at an average rate of 1 inch per hour for the next 6 hours, okay? I should say 4 hours. Okay, so if this one went to 4 hours and we put 6 on the end of that, how many hours have we gone to? What is it? 4 plus 6, guys. So this goes to 10 hours, right? And we know the rate of change. So let's go over here to, let's mark 10 on here. I think this is probably the clearest way to do these. 10. Draw yourself a little lightly dotted line down here like that. Okay. And then what does it do after that? For 3 hours. So we're at 10. Another 3 puts us at what? To 13 hours. Okay. So let's go find 13 down here. So here's 13. Let's get our little, right? All right. So after the 13 hours expired, it started snowing again, back at 1/2 inch per hour for how long? So how many hours does that take us out now? 13 and 4 would be what? To what? 10? 17 hours now. Let's find 17 down here. So that would be here. Get a little. And I guess, like, you get better at these, you won't need to put the dotted lines for the intervals in there. I think that might be the most helpful thing. Next 4 hours, and then the storm was over. So that's as far as we're going to go, okay? So let's take a look at the first interval. That's from midnight to the first 4 hours, right? What was the rate?
1/2 inch.
1/2 inch every hour, right? That's rise and run, isn't it? Okay. So 1/2 inch. So after the first hour, we're at 1/2 inch. After the second hour, where are we? 1 inch, right? Okay. And then the third hour, And then at hour 4, okay? Are you with me on that? So maybe you take your straight edge, your ruler, let's sketch that in there. And after that, what happened out there for the next 6 hours? Different rate now. Instead of half an inch, what is it? 1 inch per hour out to 10 hours. So let's pick up where we left off. So from here, instead of going up a half, we're going up how much? Right. Well, technically it's up 1/1, right? But 2/1 because it's going by halves, right? So let's go for the first hour up a full inch, right? The next hour up another full inch. Next hour up another full hour, full hour, full inch. Right? So you see how the dotted lines are in there? So like now you know where to stop instead of like going back and trying to figure out in your head where it's supposed to stop, right? So then we'll connect those with the, don't you touch those. That's you what, Mr. Miller? I would use a straight edge for that, guys, especially if it's on the Regents exam. Okay? In fact, I think I will. Okay? All right, so now we're starting at hour 10, going to the next interval. What did it do then? So what kind of line will represent stopping for 3 hours? Horizontal, right? For 3 hours. So from here to here. Okay? Then after, so that was out, that took us out to hour 13. And then what did it do? Snowed for half an inch an hour for the next 4 hours, out to 17. So now we change back to the half an inch rise and run. All right, so every 1 hour up half, another up another half, like that. Yeah. Okay. You kind of get the idea with these? So it might be kind of tough, like if you're just reading that and trying to graph as you're reading it, you might get lost in the weeds, right? So that's why I have you maybe figure out what your intervals are, draw some dotted lines if you like, right? Okay? Does everybody think they're not gonna, wouldn't be able to do this if they saw it on their own?
Mm-hmm.
And so here's a follow-up question. Read that follow-up question if you would. They're actually talking about something that we're going to look at in another section, but this is okay to preview it here. They're talking about average rate of change here. Oh, these different lines yet. Average rate of change. Okay. So, like, as we went from midnight out to the 17 hours, was the rate of change the same? It kept changing, right? So they're asking for what would be the average rate of change over the whole thing, right? How many inches per hour on average did it fall? Well, what would you need to know? What do you think you would need to know? The total number of inches from start to finish, right? Over what? The total amount of time from start to finish, yeah? Okay. So what was the total number of inches from start to finish? Huh? Look at your graph. Everyone look at the graph. What was the total number of inches from hour 0 to hour 17? Everybody agrees 10 inches, right? And what was the total time of the storm? How many hours? 17 hours, right? Okay, so now it's just going to be like unit rate, isn't it? They want inches per hour. 10 inches per 17 hours, right? All right. What are you going to do? Get it for 1 hour. Got your calculators there? And by the way, does it tell you what to round it to?
The nearest hundred.
The nearest hundredth. On the Regents exam, if they tell you to round to the nearest hundredth, and you round to, say, the nearest tenth, you'll lose points. They're real picky about that. So when you do 10 divided by 17, what do you get, everybody?
5, 8, 8, 2, 3, 5, 2.
Okay, but we're going to round to the nearest hundredth, right? So what would it be? How many decimals is that, the nearest hundredth?
3.
Those tens, hundreds, thousands. Huh? 2, isn't it? So what is it? 0.59 inches for 1 hour. Okay, that's how you get average rate of change. And we're going to do some stuff like that later on. Any questions on this guy? Yeah. All right, the next one, this shouldn't be too difficult here. I'm going to read this over. All right, so we got a bee whose height above the ground is being graphed over time in seconds. All right? And they want the intervals when the bee's rate of change is 0. What parts of the graph would that be? Everybody agree it's the horizontal parts, right? How often is his height the same, in other words? Quite specifically. Give me a number of times that it doesn't change.
2 to 6.
How about right there and right there, right? Okay, so the answer to this would be, and we could do it even without the mathematical notation, right? So from what to what? From 2 to 6 seconds, right? And from what to what? From 14 to 15 seconds. This one's not that hard, right? Okay. Explain your reasoning. Why? How do you know?
Because he's not going up or down, so he's not
How do you know from the graph, though, that that's the case?
the horizontal line.
Right, because the graph is horizontal on these intervals, right? So I would say the graph is horizontal on these intervals. Meaning what?
Meaning,
0 rate of change, right? We say, or specific to this, oh yeah, they use rate of change, right? Okay, so we use that too. So meaning 0 rate of change. All right. Any questions on this one, you guys? Number 3 on the next page. It looks a lot like the number 1 that we just did, doesn't it? We finish this one up. I'll give you a second. Take a look at number 3. We got this. All right. Well, good. That's all right. All right. So I want you to read this over. And if you remember what we did in number 1, that's what I want you to do. So as you read stuff up here, tell me to what hour it's talking about, right? And then go down to your graph and draw some vertical lines for the intervals as you write them up in here, okay? So everyone, do that now on your own, okay? Let's see if you can kind of replicate what we did in example 1. And by the way, this one, you probably want to not say to what hour, but to what time. Just look at the horizontal axis. Is it in hours or actual time of day? Time of day, right? So you'll want to figure out like to what time each thing happens. Okay? And there is a typo. This should say to 50 degrees. Well, not E, all right? Fahrenheit. Okay. All right. So read it. Figure out what interval they're talking about in each case, and then put those into the graph.
Wait, what's it mean by drops?
Okay. All right, this one will be going from to 10 a.m. an hour. And let's see, 10 a.m. the next 6 hours would put it at what time? 4 p.m., right? Okay. Just checking you guys. And then it stays steady for till 6 p.m., so we'll just say 2. I'll just write it down to be consistent. And after 6 p.m., 2 more hours, we'll put it at 8 p.m. Okay? And this temperature steadily drop until midnight. Right? That's 12 a.m. So I'll put my lines in there. So from 6, actually one there because it doesn't start right, to 10. And I think it was at 4. And then what we say, 8 and 12. So 8. And then at midnight. All right. You guys agree those will be the intervals? Help you out, all right? All right, let's get these rates then. Temperature was 50 degrees for the next 4 hours. So I'm going to find 50. Here's 50, right? Let me just read that again. Let's see. At 6 a.m. temperature was 50. Oh, yeah. There should be a period there. Okay. And for the next 4 hours, so it started at 50, right? And went up 3 degrees per hour. What are we counting by here? So that's 52, 53, 54. No. Whoopsie daisy. Going by 2s, right? 52, 54, 56, 58, 60, right? So 3 degrees per hour is not quite exact, right? So let's just see if we can go from 50, 1, 2, about halfway. Yeah, 3, and then 1, 2, 3, 1, 2, 3, like that. And over here and go 1, 2, 3. It should be about there, yeah? Everybody's first line looks like that. 3 degrees per hour. And what's the temperature here? What's the temperature at 10 a.m.? Huh? 62, isn't it? Oh, darn it.
You erase your
62. Okay. And then what does it do? For the next 6 hours, then it rose 2 degrees per hour out to 4. Okay. So we'll go out 1 hour, it's up 2. It's just going to go like that, right? Out to 4. Set the defaults on that. Like that. And then what did it do? And it stayed steady until 6. And then going to be our horizontal line. Oh, I didn't put one at 6, did I? So from 4, let me make sure I didn't mess that up. I forgot to put a dotted line at 6. So then I'm going to go straight across here because it's held steady. And then what did it do? The next 2 hours it dropped 1 degree per hour. So every hour it went down there and down there. Oh. That, and then what happened?
Drop until 56.
Oh, so until 56, right? So they give us a rate of change, they give us an ending temperature, so we got to find 56. So here, between here and here, it went from here down to 56. So down to there. So 56, right there. Oh, I didn't put that line in. I did look there. Now we got to drop from here to here. All right. Raise your hand if you understand how to do one of these now. Raise your hand if you don't quite understand. Some of you didn't raise your hand in either case, so I'll ask. It's a binary question. Raise your hand if you understand how to do it. Raise your hand if you're not sure. Okay, what is it that you're getting hung up on? What part of it are you not unsure about? On the what? I can't hear you. Oh, on one of them? Did you say?
Yeah, my first time.
Oh, well, so you understand it, you just misread it or something, and that's, so it sounds like you understand it, you just misread. That, huh?
It might interrupt me when I was reading it, and
Oh, yeah, okay. Well, and I did that myself too, so I think you got it. I forgot to put in the 6 o'clock line too, so that happens. Let's look at the follow-up here real fast. State the entire time interval for which the temperature was increasing. So from what time to what time?
6 to 4.
Right, it's this section here, even though different rates, right, that's still just increasing. So from, gee, with this, go away, why is it? All right, from, what was it, 6 a.m. to 4 p.m. That's our time interval for increasing. Okay. So determine the average rate of change in degrees per hour from 6 p.m. until midnight. Okay? So what was the temperature at 6 p.m.? What was that temperature?
74.
74, right? And then what was the temperature at midnight? 56, right? So it went from 74, ended at 56. So what is 56 minus 74? Notice what I'm doing there? What's 56 minus 74, kids? It's negative 18. Does that make sense that it's negative? Why does that make sense that it's negative?
Because you're subtracting a bigger number from the 2.
Right, but just in terms of the problem, the temperature's going down, so wouldn't that be a negative value, right? So negative 18, okay? Degrees. And what's the total time that happens? 6 to midnight. what's 12 minus 6 o'clock? How many hours? 6 hours. So what's our ratio? What over what? Negative 18 degrees over 6 hours. And they want per hour. So what is that?
Negative 18 divided by 6.
You better not touch your calculator. No, don't. Come on, man.
33.
Not 3, but
Negative.
negative 3 degrees per hour. The average rate of change. So we're getting a preview of the average rate of change. You notice that we had to do some subtracting, right? To get totals. Yeah. There's a couple of quick ones here. We can. I'd like to save number 5. All right. Take a look at number 4. Remember about functions? Oh, this is just not always increasing. And notice the interval. What's the interval? From x of what to what? Negative 2 to positive 2. So maybe I'll do this, right? Just on the first one. And is there a key word in this?
Not.
Not. Okay?
But that one's increasing, so it's not 1.
All right. So not always. So, right? So you're looking between, on all of these, you're looking between negative 2 and 2. So here it'll be from negative 2 to 2 and between negative 2 and 2. Which one of these is not always increasing between the intervals of negative 2 and 2? Which one? Oh, you. Which choice? Is it not always increasing between negative 2 and 2? Huh? Choice 2. So starting here, actually it starts here, it looks like it's increasing. Right? From there to there, it does look like it's increasing. Right? Going up. Which one is not always increasing? Go ahead.
Number 1.
Yeah, what do you
Number
start?
1, 3.
3. From here it's increasing, and then before you get to 2, it starts decreasing. So not always increasing. Yeah. Yes. And we have one more. I think we'll finish this one up tomorrow. Or maybe you can do it on your own. Remember that piecewise we did? And the other, make a table of values, something like that, right? But make a note of where there's an equal to and not an equal to sign there. Okay?